The temperature entropy diagram of a reversible cycle is given in the figure below. The area under the graph is the heat transfer to the heat engine during the processes. Find the efficiencies of the engine. To find the efficiencies of the engine, we use this formula, where the eta is the efficiencies of the engine, equal to 1 minus Qc over Qh. Qc is the heat transfer from the engine to the cold reservoir, and the QH is a heat transfer from the hot reservoir to the heat engine. It is given that the area under the graph is the heat transfer to the heat engine. Means that to find the efficiencies of the engines eta, we need to calculate what is the area under graph, so that we know the value of the QC and the value of the QH. The cyclic process given now involves three thermodynamic processes. This is one, this is the second one, and this is the third one. So now we call the heat transfer in this process as a Q1, and in this process is a Q2, and in this process is a Q3. Now we need to know which one is considered as a QC and which one is a QH. In this process, the Q1 is positive value, because from the graph we know that in this process the entropy is increased, and the entropy change is positive when the Q is positive. Therefore, we know that this Q1 larger than 0, and that means this Q1 actually is the heat transfer to the heat engine. So now Q1 is equal to QH. Based on the same reasons, we now know that the Q2 should be less than 0. That means this Q is the heat transfer from the heat engine to the cold reservoir. So Q2 should be set equal to the QC. Why Q2 is negative? From the entropy change we know, because the entropy change in this process is the negative value. That means the entropy is dropped. Entropy drop means that the heat is transferred from the engines to the cold reservoir. In the last process, the entropy value is fixed. That means the Q3 is equal to 0. So now what we need to do is to find what is the value of the Q1 from the area under the graph, and also Q2 from the area under the graph. Please take note that this Q2, although is the heat transfer from the heat engine to the cold reservoir, but we will only consider the magnitude only. So we always take the positive value for the QH and the QC, and after we find it, then we will substitute into this formula to find the efficiency of the engine. For QC, which is the same as the Q2, the area under graph is given by the area of this rectangular shape. So that means the area now is equal to this T naught multiplied with the 2 S naught minus the S naught. Therefore, we have the QC equal to T naught times the S naught. QH is equal to Q1 in this process. So we can find from the area under graph, which is the area for these trapeziums. So it is equal to half times 2 T naught plus the T naught, and multiply with this length, which is a 2 S naught minus the S naught. So we obtain the QH equal to 3 over 2 T naught S naught. S naught is come from this, and this is a 3 T naught, so we have 3 over 2 here. So QH equal to 3 over 2 T naught S naught. Now to find the efficiencies of this engine, we can apply this formula and substitute the QC and the QH in this formula. This is the result of the substitutions for the QC and the QH. So T naught and S naught can be cancelled. So in the second terms, we will obtain the reciprocals of the 3 over 2. That means it is 2 over 3. So eta is 1 minus 2 over 3. And finally, we obtain that the efficiencies of this engine is equal to 1 over 3.